Gravity is what keeps your feet firmly planted on the ground. That's why the average person can only jump about 1.5 feet straight up. But if we had to live on another planet, say Venus or Saturn, let's find out what difficulties we'd have to endure there. We'll try Mercury first, as it's closest to the Sun. The gravity on this planet is less than half that on Earth, so you'll be able to jump about 4 feet high. That is, if you can stand the temperatures. On the sunny side, the heat reaches 800 degrees. To be there is like standing neck-deep in dark red lava on the slopes of a volcano. Oh boy! Night won't bring much respite either. Scorching air will quickly chill to minus 280 degrees. You'll also have to be patient, since one day on Mercury lasts 176 Earth days. Well, hopping from this inhospitable place to even less welcoming Venus. You'd be able to see Earth from here if not for the whirling mass of clouds above. They create a monstrous greenhouse effect, as well as immense atmospheric pressure. If you were to jump here, you'd make it just shy of 1.7 feet high, because the mass and size of Earth and Venus are almost similar, with Venus being a little smaller. Besides the constant temperature of a blazing furnace, rain here wouldn't bring relief. The clouds up there are made of sulfuric acid. Skipping our home planet, we go straight for its moon, Luna as it's otherwise called. Gravity here is less than a fifth of that on Earth, so if you jump, you'll rise almost 9 feet in the air and won't touch the ground again for several seconds. It's hard to believe this desolate piece of space rock makes tides on Earth happen. And if you stay on the moon long enough, as in a couple million years, you'll see how much further it's gone from our home planet. Next destination is Mars, the red planet. Here, a vertical jump will take you about 4 feet in the air, if there was any air to speak of course. Mars has an atmosphere, but it's much thinner than on Earth. If you stay here until evening, you'll be able to marvel at a beautiful blue sunset. And you can probably see a mountain from here. That's Olympus Mons, the tallest mountain in the solar system. It's almost 3 times taller than Everest, and it's also a volcano, by the way. Leaping from here to Phobos, one of the 2 moons of Mars. Plant your feet firmly and don't be tempted to jump. Gravity here is so weak that you won't be able to return. Phobos is really small compared to other moons in the solar system, no larger than a big asteroid. It's almost 100 times closer to its planet than our moon to Earth. Eventually, it's doomed to be pulled critically close to Mars and shatter. Scientists believe Mars can obtain its own rings then, much like Saturn. Now, we're going to a really weird object. It's called Ceres, and it's the largest asteroid in the solar system. So large, in fact, it was later classified as a dwarf planet. It's almost exactly halfway between Mars and Jupiter, somewhere in the main asteroid belt. If you jump here, you'll be taken up almost 52 feet and then slowly fall back. Ceres is so massive that it accounts for a third of all mass in the asteroid belt. Fast forward to the next waypoint, Jupiter. Being a gas giant, this planet has no solid surface, so jumping here is irrelevant. But if you must, you could only hop about 6 inches high. Jupiter is more than 10 times larger than Earth and 300 times as massive, so its gravity is enormous. There's also a perpetual storm on its surface that's been there for at least 4 centuries. Although it's getting smaller with time, at the moment our whole planet could fit into that storm. Our next stop is Ganymede, the largest of Jupiter's moons. It's solid, so you can easily jump here and make it over 10 feet high. This moon is larger than Mercury, but its mass is significantly lower, which makes gravity rather weak. Ganymede is covered in thick ice, and deep beneath that is a liquid metal core. This core is why Ganymede is the only moon to have a pretty strong magnetic field. Next, we go to Saturn, the second gas giant of the solar system. It's only slightly smaller than Jupiter, able to fit 9.5 moons in it, but way less massive. If it had any hard surface to jump from, you'd be able to hop as high as 1.4 feet in the air, almost as high as on our planet. Saturn is most famous for its rings, which are particles of dust and ice left from impacts with different space objects. It spins so fast around its axis that it has flattened itself almost into an oblong shape. It also has 62 moons, only 5 fewer than Jupiter. Let's explore one of them right now. Hopping further, and here we are on the largest moon of Saturn, Titan. Jumping here will take you just shy of 11 feet high. The atmosphere of this moon is most peculiar. It's heavy and mostly consists of nitrogen, making the surface appear hazy. It's also made almost entirely of ice, but there's rock underneath, and water is only thought to be deep below, near the core. And one amazing thing on Titan's outside are cryovolcanoes, volcanoes that spew ice instead of lava. Next is the dark and lonely Pluto, formerly the 9th planet, but now no more than a dwarf planet. Its gravity is somewhat lower than that of Triton's, and you could jump over 25 feet high here. Pluto is too small to be a fully fledged planet. It's smaller than many moons, including ours. Its atmosphere appears and disappears at times. When Pluto is closer to the Sun, the ice on its surface evaporates to become the atmosphere. But as soon as it travels further, the gas layer goes away. So hold your breath. Let me introduce my spaceship. The name of this super-fast beauty is the Invincible, and people won't create anything of the kind for the next several decades. The thing is that space distances are seriously long. That's why traveling there would take way more time than you'd like to spend on the road. For example, Voyager 1, a space probe launched in 1977, was traveling out of the solar system at the speed of 40,000 miles per hour. If my spacecraft moved at the same speed, it would take me a whole 77,000 years to get to the nearest star. I mean, really. It would also take me more than 1 billion years to cross the Milky Way galaxy. But luckily, the Invincible is much faster than that. Also, I almost forgot to introduce my companion. Sorry, Liam. You see, Liam is a robot with AI. You know, artificial intelligence. That's why I have high hopes for him. I'll have someone to talk to during the flight, and he can help me if things get really tough. And now, let the journey begin. Here we go. 3, 2, 1, blast off! Wow, the Earth is growing smaller and smaller by the second. It seems like no time has passed, but our spacecraft is already 200 miles above the surface of our planet. Since it's daytime, I can clearly see the Great Lakes shining in the sun. And oh boy, I've just spotted something moving to the left of my ship. Could it be? Yes, it's the International Space Station. Did you know that the station is the most expensive single object in the world? No wonder, with a price tag of $100 billion. This money would buy you 250 Boeing 747s or 2 Louvres with all the paintings and artwork inside. For my spacecraft, the ISS looks pretty big, but I shouldn't be surprised, since the length of the station is over 350 feet, which is more than the length of a football field. But I don't have time to linger, a black hole is calling for me. Now I'm about 1,300 miles over the surface of the planet, and I start to spot satellites here and there. I've read that among satellites, there are low and high flyers. And while the lowest flying ones move approximately 1,250 miles away from Earth, which is the length of 4.5 Grand Canyons, the highest reach 22,000 miles into space, which almost equals the Earth's circumference, measuring about 25,000 miles. By the way, few people know that satellites travel at a blinding speed, from 7,000 to 18,000 miles per hour. Also, the higher a satellite is, the slower it moves, relatively speaking. For example, the Weather Tracking GOES system of satellites orbits the Earth once a day at a distance of 22,000 miles above your head, and reaches a maximum speed of 7,000 miles per hour. Well, the satellites are being left behind, and my spacecraft has already taken Liam and me toward the Moon, about 240,000 miles away from Earth. That's the same distance you would go if you went around our planet 10 times in a row. From here, Earth looks like a small bright blue ball hanging in the middle of nowhere. And you know what else? From my spacecraft, I can clearly see that the Moon isn't a perfect sphere. It's shaped more like like an egg. Wow. Anyway, bye-bye Moon, we're headed somewhere even further. I see Mars, Jupiter, Saturn, and Neptune passing by in all their glory. And look, there's Pluto, who used to be a planet but was later demoted. From here, Earth looks like a small star that's getting fainter and fainter as I'm moving further away. But wait, what's that? Some object is approaching me at a high speed. Could it be Tesla? Whew! That was close. The thing just avoided a collision at the last moment, and everything happened too fast to see it clearly. But I'm pretty sure what I just saw was a Tesla. Right now, I'm already really far from Earth, like 100 astronomical units away. The thing is that space distances are so vast, you can't even calculate them in miles. That's why scientists use the term astronomic unit, which equals 93 million miles, the distance from the Sun to Earth. That means, right now, I'm 9.3 billion miles away from our planet. But what's happening? Why is my spaceship shaking and rocking so much? I see. We're entering the termination shock, the place where solar winds coming from the Sun travel at a speed of 250 miles per second and collide with the material that makes up the galaxy's background. Ah, there. We made it through unscathed. But there's another trial ahead, the Oort cloud. That means two things. First, we're on the outskirts of the solar system, and second, we'll have to get through a cloud of icy objects orbiting the Sun at a distance of 100,000 astronomical units. In other words, it's 1.87 light-years away from our star. Whew! It must be my lucky day, since we got through the Oort cloud with just a couple of scratches on the spacecraft's skin. And voila! We're heading out of the solar system just 1/10 of a light-year later. By the way, if you were trying to reach this point by car, the trip would take you more than 19 million years. And even if you piloted one of the fastest spacecraft that exists nowadays, NASA's New Horizons, you would still need 37,000 years to complete the journey. So bring a big lunch. Alright, we've left the borders of the solar system, and now I'm sitting in my spaceship cabin watching comets and asteroids pass by. Time to think about my destination. In the center of pretty much every galaxy, there's a supermassive black hole. For example, one is sitting right at the heart of our Milky Way galaxy, about 27,000 light-years away from Earth. But even my ship wouldn't be able to get that far before my 100th birthday. That's why my destination is the stellar black hole nearest to Earth and much smaller in size, but no less mysterious. It's V616 Monocerotis, also known as V616 Mon, located 3,000 light-years away and weighing the same as about 9 to 13 of our suns. A black hole is an eerie place, where those laws of physics we studied at school stop working. If a massive star runs out of its star fuel, it becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new thing gets so strong that nothing can escape it, not even light. Right now, we're approaching the black hole, and very soon I'll send Liam to explore it from the inside. I won't go further than the horizon, also known as the point of no return, and you can probably guess why, right? Once an object crosses this invisible line, it can't turn back, even if it changed its mind. Anyway, Liam says he's ready to start his journey. There he goes, bravely plunging toward the black hole while I'm recording everything that's happening to him. He's accelerating. It looks like he's contorting and stretching, as if I'm looking through a huge magnifying glass. Interestingly, the closer to the horizon he is, the more slowly he seems to move. He's trying to send me encoded light messages like we agreed to in advance, but the light waves stretch to redder and lower frequencies. I'm okay. I'm okay. What's happening? Liam just froze, as if a gigantic finger has pressed a pause button, and now some force is stretching him thinner and thinner. I've read about this phenomenon. It's the infamous spaghettification, which happens in a super strong non-homogeneous gravitational field. The black hole's gravity force is stronger at his feet than at his head. That's why he's getting stretched out like a piece of spaghetti. Also, the sensors inform me that Liam is getting hotter and hotter, and then nothing. He just disappeared. and I can't see him anymore. But since I did my research before the trip, I know that Liam is in the state of free fall now, and feels no more stretching, scalding radiation, or gravity. Unfortunately, the connection is lost, and he can't tell me anything about the inside of the black hole. This is a moment I didn't think through well enough. Anyway, I hope you're okay out there, my friend, and I think I'll head home to get ready for my next space trip.
Well, what's up? My name's Zid, and I'm from a planet in a place you call the Andromeda Galaxy. I'm in high school, and I have this assignment to find out what will happen to your solar system's perfect harmony if it loses a planet. So I poof one of yours away with this ray blaster and track any changes. Don't worry, I'll put them back. Sort of. So, let's give it a shot. I'll start with the planet closest to the Sun, Mercury, right? Oh, it's so small I nearly missed it. Here we go. Okay, with Mercury gone, how's Earth looking? No changes in the solar system. I saw that coming. It's all about gravity. Every object that has some mass attracts other objects because of its gravitational force. The larger the mass, the greater the force it has. Mercury is the smallest planet in the solar system, so it's not too massive in space terms. The second most important factor is the distance between the objects. At 50 million miles away, Mercury is no doubt far from Earth, so the gravitational force between the two of them isn't that strong. Okay, let's put Mercury back and move on to Venus. It's the hottest planet in your solar system. One day here is almost 117 Earth days. I'll try the blue button this time. Oh, did you see that? It just froze and broke into pieces. And again, nothing really changed that much. Well, except you, Earthling, just lost the second brightest object to light up the night sky. Second to the moon, of course. I suppose that's why they call Venus the evening star. Looks like it got way darker after sunset than it used to be. Alright, I'll reassemble Venus now and head to your home planet. Earth, the one floating rock in the system that's in that precious habitable zone, the perfect distance from your star to sustain life. Hey, I was just kidding. I'm obviously not going to poof Earth away, so let's head to the red planet, Mars. I know humans are planning to send a mission there. Would you personally want to go? Tell me about it in the comments below. Let's see what'll happen when I spin the red planet so fast that it shoots out of the solar system. Woohoo! Bye, Mars! And no significant changes again. This might be good for Earth in a way. There's a massive asteroid belt between Mars and Jupiter. Asteroids, as you know, aren't Earth's best friends. Jupiter holds them together with its strong gravity, but from time to time they break free and start moving toward the Sun. No surprise really, since its gravitational pull is impressive. Mars also has gravity to boast and acts somewhat like a slingshot that speeds up asteroids in the direction of Earth. So, no Mars, no slingshot, and the chances of the blue planet getting hit by an asteroid go down. Finally, the moment I've been waiting for. Time to experiment with the largest planet in your solar system, Jupiter. It weighs 3 times more than all of its neighboring planets combined. How am I going to get this giant out of the system? I know! I'll use the shrink ray and make it 2 billion times smaller first. Now I can just throw it like a baseball. Uh-oh, I think I made a huge mistake. With its massive gravitational force, Jupiter has protected Earth from asteroids and other space debris for the past 4.5 billion years. Now the Sun's gravitational pull is sending all that stuff toward the inner planets, and that includes Earth. There will also be some small changes in the orbits of other planets, but that would be some thousands of years later. For now, I gotta figure out a way to get Jupiter back before the Earth is doomed. Maybe this button? Oh, okay. How about this one? I'll just push all of them. Woohoo! Brace for impact! Woo! Whatever it was, it worked. The giant is now resting peacefully back in its place, and Earth is saved. Sorry about that, must have given you a real scare. I'll try to be more careful with the rest of the gas giants. It's time for Saturn. You can't mistake it for any other planets, thanks to those gorgeous rings. Scientists say they'll disappear one day as Saturn's immense gravity pulls them down in an icy rain. But that won't be for 300 million years from now, so no worries. I guess I'll have to push the red button for this one. Bam! And it's gone. Such a massive planet, the second largest in the solar system, can't be gone with no consequences. Look at Jupiter and Uranus. Their orbits have slightly shifted. Other than that, I don't see any changes to the other planets. Saturn is just too far to influence them. That's good. Wouldn't want another close call like what happened when I took Jupiter away. Uranus is massive as well, the third largest planet in the solar system. I'll try this super powerful space lasso to move it out of the way. Got it. Now I'll just throw it out of the system. And, nothing so far. Looks like it's the same story as it was with Saturn. Uranus is so far away from the inner four planets that its disappearance has no effect on them whatsoever. But I can see that it did mess things up a bit for the outer planets. Alas, we've come to the last planet unless you're on Team Pluto. Sorry, but I'm gonna go with NASA on its status and exclude it from today's experiment on your happy neighborhood of planets. Anyway, it's Neptune's turn. Beyond it, you've got the Kuiper Belt. It's a donut-shaped region of icy objects and a ton of dwarf planets like Pluto. Neptune is so close to the outer edge of the solar system that I'll just kick it out. Whoa, look at the Kuiper Belt, it's going crazy! Without Neptune's gravitational pull keeping things stable, orbits are crossing and celestial bodies are crashing into each other. Check it out! Pluto's orbit is misshapen now too. Neptune pretty much controls it as well, but it's too far away from Earth to affect it in any way. I wouldn't want anything to happen to little Pluto, so let's put the 8th planet back where it belongs. But I'm not ready to finish the experiment just yet. I need to find something that would really affect life on Earth. The Sun is the obvious answer, but the mess and chaos from its disappearance would be too massive and irreversible, so I'll leave it where it is. What about the Moon, though? I've always had this secret dream to turn it into Swiss cheese and bite off a piece. It's time. Oh my. What just happened to the Earth's axis? It's so tilted even more than it was before. The weather down there has gone wild too. There are no more seasons at all, and new ice ages are on the way. The ocean tides have become much lower than they used to be. And is the planet starting to spin faster? Yup, the day now lasts only 6 to 12 hours, because there's no more pull of the moon to slow down the Earth's rotation. There are also no more lunar or solar eclipses to watch. And the nights are so dark with nothing but billions of stars and Venus, which together are still way dimmer than the moon, to light the sky up. None of this sounds good for life on Earth, so I'll de-cheesify your moon and put it back where it was. It looks like out of all the planets in your sun's complex system, only Jupiter's disappearance would be a major problem for Earth. So, I guess it's true what they say. The solar system really is a delicate and harmonious balance.